Okay, today we're going to be looking at SUVAT equations, which are equations of motion for constant acceleration. I'll really try and highlight that. These are equations of motion for constant acceleration. So please, please, please do not try to use these if the acceleration is variable, i.e. a function of time or function of displacement. Everything stems, when it's constant acceleration, from your velocity time graph. I've done a rough sketch of a velocity time graph where the velocity goes from u to v. It's supposed to be a straight line over time t. Now, the two facts about the velocity time is the acceleration is the gradient of the line, gradient off the curve, but it's a straight line, so gradient of the line, and the displacement is the area under the curve, the area under the line. So from that we get the first two SUVAT equations. So A is the change of velocity, v minus u divided by the time. We rearrange that, times by t to get at as v equals u plus at. And that we'll call our first equation of motion. S is the area under the curve, it's the average of the parallel sides, which are u and v, so it's a half bracket u plus v times t, and we'll call that one our second equation of motion. Now, what you'll notice is that every single one of these involves 4 of the 5 of these things here. S for displacement, u for initial velocity, v for final velocity, a for acceleration, t for time. So this is the one without S. This is the one without A. And when we do our setups, that's how we're going to think about it. We're going to put our information in and think, well, the equation I need is the one without so-and-so, quote it, stick them in, work it out. To get the other 3, all I'm going to do is a bit of algebra. I'm going to take from this thing here, for example, t. I can rearrange this one to get t equals v minus u over a, and I'm going to sub that into equation 2 with a slight difference. I'm going to, instead of having u plus v, I'm going to write v plus u and then times v minus u over a. So I get 2 brackets, v plus u times v minus u, which is v squared minus u squared over 2a. And that, when I times by the 2a, move the u squared across, v squared equals u squared plus 2as. That's the one without t, eliminated t. What I can do with equation 1, v equals u plus at, is also substitute that into equation 2 to get s equals a half bracket u plus at times by t, and ties it all out. A half times 2u is u times t, and then plus a half at squared. So I'll rewrite that as s equals ut plus a half at squared, and that's my fourth one, the equation of motion, the one without v. I can also do the one without u by rewriting that as u equals v minus at and subbing that into equation 2 as well to get s equals a half v minus at plus v times by t to get s equals vt minus a half at squared. This is probably the one you're going to see the least of, but everything stems from, everything stems from the first view there. That's a bit more like it. There. So v equals u plus at, the one without s. S is a half u plus v times t, the one without a, and so on. So let's look at how we apply some of these then. My setup is like this. I'm going to look at the information given. So example 1, I'm taking it from the sheet, said when leaving a town, a car accelerates from 50 to 80 in 5 seconds. Assuming the acceleration constant, find the distance travelled in this time. So S is what I'm after, distance, displacement. Be aware of that later on. From 50 to 80, constant acceleration, but it doesn't tell me what it is. I'm not interested in it in 5 seconds. So I need the one without a. So I'm going to quote S equals a half bracket u plus v times t. So it's a half 50 plus 80 times by 5, and then press buttons work it out. So we've got 130 divided by 2, 65 times 5 is 325 meters. talk about units in a bit, because that has an effect as well. Example 2 says, a small French car, I'm not sure why that's relevant, but there you go, travelling along a straight motorway overtakes a lorry by accelerating from 20 to 25, so a similar setup to example 1, but in this case they give us the time, and the question wants the acceleration. So this is the one without s, so obviously it's v equals u plus at, so 25 equals 20 plus 10t, sorry 10a even, and a is 5 over 10, 0.5 meters per second squared. Okay, so stick it in, substitute, work it out. Don't try and be too clever at this stage here. Don't try and do too much, is basically what I'm saying there. Third example, the train accelerates at 0.5 meters per second squared along a straight track. It covers 0.5 kilometers. Now, all the units have to balance out. We're talking about meters, seconds, meters per second, and so on. So when you're given the distance in kilometers, you must change it to meters, in that case there, and has a final velocity of 25 meters per second. We want both the initial velocity u and the time t. So I'm going to do them one by one. I'm going to do the one without t first, which is v squared equals u squared plus 2as. And stick in the v squared, 25 squared, 625, equals u squared, and then 2 times 500 times 0.5 equals 500. So u squared equals 125. U is whatever root 125 is. It's about 11.2 meters per second. I'll have to just check it. Root 125 equals 5 root 5, 11.18, 11.2. Remember, accuracy, don't be too accurate. In fact here, because I've got a 2-figure value, 25, I can quote 3 figures at the most in my answer. Now to find t, I'm going to quote the one without u, because if I've made a mistake with u, and also if I use a rounded off answer, I'm not going to get t right. So I'm going to quote s equals vt minus a half at squared, 500 equals 25 t minus a half times a half minus t squared over 4, oh gosh almighty, rearrange it, t squared, and then minus 100t and plus 2000 equals 0, t minus 50 all squared minus 2500 and plus 2000 equals 0. I've got an old calculator, I can't use my regular calculator to solve it, so I've got to do it the old-fashioned way. So that's 500t equals 50 plus or minus root 500. The t minus that there gives me two answers. I'm after the first of these. I've convinced myself why that's the case. Because of the nature of this thing, I'm going to get two answers, but I'm looking at the first one. So 50 minus root 500 equals that, 27.6 seconds there. I'll just use v equals u plus at, t equals v minus u over a, 25 minus my 11.2 equals, and then divided by 0.5 equals, that's roughly 27.6. If I'd have used the value I had for u, 11.2, that's the answer I would have got. So I'm happy with that. Last example from this one. P is a point on a slope 10 metres from the bottom. A ball is rolled up the slope from P with initial velocity 8. It undergoes a constant acceleration of minus 4 metres per second squared. So the minus is because they're specifying the downwards direction. So we're taking upwards to be our positive there. How long does the ball take to reach the bottom of the slope? So at the bottom, since it started 10 metres above the bottom, I'm using s equals minus 10. You've got to be careful with the fact s is displacement. These are vector quantities. S, U, V and A are all vector quantities. So in this case here, it's the one without V to find T. So I'm quoting S equals UT plus a half A T squared. So minus 10 equals 8T and then minus 2T squared. I can move it across to be positive and halve it, move that across and halve it, minus 4T minus 5 equals 0, and I've got T minus 5 T plus 1 equals 0, T equals 5 seconds because it's a time and we can't have a negative time. Part B says how far up the slope did it travel. Now this is a total, use the initial velocity u, the acceleration was still minus 4, but it's a different point, different setup. I need to find the distance or the displacement from where it started, and at the top is when v is equal to 0 because it's gone up with velocity u to the top when its velocity was 0 and started going down again beyond where it was set off from, and then it hit the bottom 10 meters away from where it was set off from. So in this case it's the one without t, so it's v squared equals u squared plus 2as. Be aware that your signs should take care of themselves, particularly if you're working out v. If you ever get v squared to be negative, you've done something wrong with your signs. So 0 equals u squared 64. 2a is minus 8s, so s is 64 over 8, which is 8 meters up from where it was set off. So that's I'm just checking the question, how far up the slope did it travel? It travelled 8 meters up the slope. So in that case there, I've used my SUVATs, and these are the basic way I would do a SUVAT equation.